Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. My name is Shrithik Sekar.
And my name is Tejas and I.
And we are your hosts for episode 13 called The Chemistry of Acid Rain. Today we will be discussing the formation of acid molecules and how water in the atmosphere turns to acid rain. In addition, we will be talking about acid rain's effects on the ecosystems and how humans affect the formation of acid rain.
So if you ever studied chemistry, and even if you haven't, you might have heard of the term pH. A pH of 7 means the solution is neutral, a pH over 7 means it's basic, and a pH under 7 means the solution is acidic. So from the words acid rain, you might guess that it means rain that has a pH much lower than 7, and you'd be right. It's exactly what acid rain is. But how does it form? First, sulfur dioxide and nitric oxides are produced by the combustion of fossil fuels. When these gases rise up into the atmosphere, they can react in a few different ways to produce acids. Two molecules of sulfur dioxide can react with diatomic oxygen gas in a composition reaction to produce two molecules of sulfur trioxide. Then, each of those sulfur trioxide molecules reacts with liquid water from cloud droplets to produce H2SO4, or sulfuric acid. This is the acid that then falls to the ground with water as acid rain. Alternatively, two molecules of nitrogen monoxide can react with diatomic oxygen gas to produce two molecules of nitrogen dioxide. Then those two molecules react with water to produce nitric acid, HNO3, and nitrous acid, HNO2.
So we have these products remaining, H2SO4, HNO3, and HNO2. But how do these actually form to create acids within those cloud droplets? So what essentially happens is these molecules are dissolved into the water, and these acidic molecules then reduce the pH. That's very simple. We all know that. But what actually happens is that these molecules donate one of their H plus ions, and by the Bronsted-Lowry theory, this makes them an acid. They donate one of these H plus ions to one of the water molecules. So, for example, H2SO4 would be HSO4 minus, and that would result in a water molecule gaining a hydrogen ion, H plus, or a proton, and that would make it H3O plus. And what happens is the more of these molecules that dissociate, the more H3O pluses are created, and that makes a stronger acid. So typically, the strongest of acids will dissociate completely, and each of those acid molecules will dissociate to form a H3O plus molecule, or a hydronium ion. But what happens is sometimes these acids, such as HNO2, are weak acids, which means they do not dissociate completely. This means that most of those molecules remain intact when they dissolve in water. So most of those HNO2 molecules remain HNO2 molecules and do not dissolve into HNO and H3O plus ions. However, H2SO4 and HNO3 are strong acids, which means that they will dissociate completely in water, which gives them the highest effect when forming acid rain.
So now that we've talked about how acid rain forms and why the emission of sulfur dioxide and NOx produce highly acidic solutions, we should talk about how this acidity is measured. And this goes back to what I said in the beginning of our podcast when I mentioned pH. pH of 7 is neutral, over 7 is basic, and under 7 is acidic. But what exactly are these numbers? What is pH? Well, a pH is an easy way to understand exactly how much H3O plus is in a solution. To find pH, you take the negative log of the concentration of hydronium in the solution, and the higher the concentration of H3O plus, the more acidic the solution and the lower the pH. As we just learned, acidic rain or acid rain is formed when the strong acids, nitric acid and sulfuric acid, dissolve in water. And because these are strong acids, this means that acid rain has a very low pH. More specifically, any precipitation with a pH lower than 5.6 is classified as acid rain.
Acid rain typically has a pH between 4.2 to 4.4. And for context, this means acid rain has 630 times the hydronium ions of pure water. And normal rain is around a 5.6, so anything below that can be classified as acid rain. But why is normal rain this acidic anyway? I mean, if it's pure water, it should be falling down with a pH of 7, but this isn't always the case. This is because natural acids exist in our atmosphere without fossil fuels. The carbon dioxide in our atmosphere combines with water to create H2CO3, or carbonic acid. This carbonic acid is a weak acid, which means it doesn't dissociate as much, and therefore it has a lower effect on the pH than H2SO4 or HNO3. This means that naturally forming carbonic acid molecules will dissolve within the water in the cloud droplets and fall to form slightly acidic but normal rain, and this happens everywhere across the earth. However, acid rain is caused by excess sulfur dioxide and nitrogen oxides in the atmosphere, which occurs naturally sometimes due to volcanic activity in a region. But in recent decades, increases in human activity and pollution, notably due to electricity generation, fossil fuels, animal agriculture, factories, and motor vehicles, have contributed to the acid rain increase because they put out more sulfur dioxide, more nitrogen oxides, and overall more pollutants in the atmosphere. And this increase in acid rain has adverse effects on the environment as well as humans. For example, increase in acid rain increases soil acidification, ocean acidification, and impacts plants and aquatic life. For example, some fish eggs in freshwater seas do not hatch with a pH below 5, and this is especially concerning when you realize acid rain has a pH of around 4.2 and 4.4, which can easily throw off an ecosystem's balance. And in addition, acid rain causes around 550 premature deaths each year, which means it not only affects the ecosystem, but it affects humans as well.
Yeah, so clearly acid rain is can be extremely harmful to our environment. But what's important about this is that when the topic of pollution and saving the environment is brought up, you hear a lot about how the burning of fossil fuels traps carbon dioxide in the atmosphere, but not as much usually about how sulfur dioxide and NOx can cause acid rain, as we just discussed. So hopefully after listening to this podcast, you understand the relationship between fossil fuels and acid rain. It's yet another reason why we have to switch to clean energy if we want to save our planet.
Thank you for listening to this episode of Chemistry Connections. For more student-run podcasts and digital content, make sure that you visit www.hvspn.com.